All right, hello, let's check it out. As always, thank you for your patience. It's been absolutely awesome as always. Whenever we want to upgrade or improve something, we have to be willing to break it. And I broke a lot these past 2 weeks, unfortunately, and then some stuff broke itself. But we are here so that you can learn this next newest project. Are you ready to make stuff move? Because I am. So we are going to use this wonderful little buzzer vibration motor here. It's kind of like what's in a cell phone. Okay, and I'm going to set this up so that you can see what I'm doing. Okay, I'll bring this around. So this project's going to be kind of a step back. It's going to be a little bit easier than the last one if you made it through the temp sensor project. But we're going to put the two together maybe sometime soon. So what we first want to do is we want to attach these and remember which color's which. We have ground, VCC, and the signal in. Now, you'll see that normally we like red on the voltage and black on ground, and data is some other color, oftentimes yellow. But in this case, we are not so fortunate because the way these are connected, if we want to keep the three together, they're in some funky order. We could have flipped this over so that red was in or whatnot. We're just going to remember that red is ground, brown is the 5 volts in, and black is the signal in, all right? And we're going to come over here to our handy little knockoff Arduino board, all right? I'm going to bring it over here. See that? Cool. And what we're going to do is we're going to take, so remember, red is ground. So we want to put little jumper cables in here. You can fold them out and connect them. So I'm using blue or black as ground. All right. And then the middle one, which in my case is brown, red for VCC, that can go into 5 volts. All right. And then for the signal, this last one, black, I used yellow just to remind myself that's the signal. We are going to use pin 3 over here. All right. Now you'll see that it's already, mine's already kind of buzzing, causing everything else to buzz. That's because I already set some stuff up, some code up on it. So we're gonna shut that down for a minute, all right? We're just gonna upload a blank something, cool. All right, so now that everything is hooked up, all right, let's come and get to the coding. Again, like I said, this is going to be a little bit easier in many ways than the last project. So let's come over here, and again, we want to save it. We're going to save it, put our name. We're going to go buzz by input. All right. In my case, I'm just going to do a 2 because I already did a 1. Cool. All right. So we are going to, now that we have that all set up, we want to remember that we chose to use pin 3 this time, right? Last time with the temperature, we used pin 2. We're going to keep it that way just to help ourselves, okay? And as we step through the instructions, you can step through them yourselves too. Again, you can take the code and work with it. That's perfectly fine. Whatever ends up working best for you, all right? So the first thing that we need to do in our code is we want to define those pins. Fortunately, this time we do not need libraries. We can just go straight for defining the pin. So we say motor pin 3, all right? Oops, end that line. We're not going to need, are we going to need incoming byte? Oh yes, we're going to need the incoming byte, all right? Int incoming. So what we're doing right here is we're gonna work with the bytes themselves. But this is kind of a cheap workaround or a hack compared to some of the input output we could work with. We're just gonna start here first, all right? And I need to open my code to, there we go. So we're gonna say for incoming serial data. In this case, so previously we worked with output from the serial data, right? We got output from the DHT22. We started the serial monitor, and then we had it pump out that output data. this time we're gonna have input into the serial monitor, okay? And we're also gonna have it spit out some formatted text just to let us know what's going on. Cool. All right, so motor pin, incoming byte, we're gonna save. Now we're gonna come down. Now this is just to practice learning different data types. As programming languages have gotten more complex, and maybe I already described this, but I have to go back to those videos. They've added more specific data types. All right, in this case, it's an unsigned integer of 32-bit size. We're not going to stress out too much what that is, just like we're not going to stress out what integer int is. We're just going to use it. It's going to be this magical thing that we use. All right. So now we are going to come down here into the setup. Okay, and just like we do, we don't need to keep that, but we want to start the serial monitor begin, or serial connection. Okay, and we're going to set the pin mode. And remember, motor pin's 3, so you could imagine that getting replaced with 3, or we could have just put 3 there. And we're telling it how that pin mode's working. It's working in output mode, right? All right, and we're going to define our delay. Now remember, last time it was important to keep that at 2000 and not go lower than that. All right, but this time we have a little bit more flexibility because the buzzer is like the light. It's not quite as limited as the DHT22 in its response time. Okay, so now let's come down to the loop. Now, the first thing we want to do before anything else, remember, we want as little as possible in the loop so that it can go as fast as possible. And so if the serial monitor, if the serial connection is, if there's nothing going on, we don't want our Arduino to take any action, okay? So, and let's double check that we're connected. There we go, connected. Let's just upload that code for fun. You don't have to upload the code. I'm doing that to stop the buzzer. I had to unplug it. Cool, so we're in the loop. So if nothing's going on with the serial connection, so serial.available is greater than 0. All right. What we're going to do is we're going to take the incoming byte, right? And we're going to read it. Read. Now this function is going to run if there's something in the serial buffer. Okay, so if we put some input in, this function runs. Oops. Come back here, have some nice spacing. All right, so if the serial available is greater than 0, then we want to set the incoming byte that we defined at the top to be whatever the serial is reading in, all right? And then we want to work with that. So if incoming bytes, now the incoming byte is going to take your input and it's going to convert it into the numeric value of the ASCII values, and we'll get to that. You can actually look in the reference too. But we're going to say if the incoming byte is not equal to, so if the incoming byte is not 10, then do this stuff. But if it is 10, we'll skip past it, all right? So if the incoming byte is does not equal 10, what is 10? 10 is the return carriage. So that's this enter right here. When you press enter, it goes to the next line. That actually comes out to an ASCII value, byte value of 10. And we don't want our script to do anything when we press enter or when we send a value. So that's what this is for, okay? Now we're gonna add this fun little bit so that you can see what's going on. So we're gonna go, okay. Whoops. Cool, all right. We're gonna save it. Now before we do anything else, all right? And let's actually make that a serial print line. Cool. before we do anything else, let's verify this. Cool, everything's looking good. Let's upload that. All right, everything's looking good. And let's go to the serial monitor that's down here. So I'm gonna move that up so you can see it. All right, so remember how it says right here, if it does not equal 10, then come down here and print the incoming byte. But that's only if something's going on in the serial monitor. So nothing should be here, right? Because we didn't plug anything in. But let's plug A, 97, S, 115, R, 114, O, 111, B, 98, all right? So I plug in these, I press enter, plug in a letter and press enter. What happens if we put 1 in? 1 is actually 49, that ASCII value. Again, if you go over here, I linked the table right here, ASCII table. So we'll open it up and you can see that, all right? So we plugged in a lowercase r, and that's right here, 114, right? But I said we don't want 10, right? Look at that. So 10 is a new line feed, new line. We want to ignore that. Otherwise, every time we pressed enter, it would pump out a 10. We don't want that. O is 111, R is 114, and B is 98. We're gonna remember those, all right? Or just look back at this table. Cool. So it looks like everything's working. Nothing happens when we don't put anything in, and something happens when we do. R, we get 114. O, we get 111. Cool. Now, let's come back here, and we can comment that out because we don't need that, all right? But that's just so that we can see what that input looks like. And we're gonna come to this next step, and we're gonna use our favorite thing to make our loop code simple, is we're gonna make a function. Let's call it buzz by input, all right? And that's gonna take incoming byte, and the motor pin. Why? Just because we can. Cool, all right, and look at that. That is our loop function. Our loop is 1, 2, 3, 4 lines long, all right? And it only runs if we've plugged something into the serial monitor. Now let's come down here and let's make our buzz by input. We're just gonna make a bool function, buzz by input. Cool. We're gonna go, so remember, incoming byte is an integer. Back up at the top, we defined it as int incoming byte. So we're gonna go int input, and same thing with the pin, int pin. All right. Now let's come down here. Cool. So I gotta open the instructions to make sure I didn't leave any notes out. All right. Cool. So we want it to print for us whenever stuff happens, so that it communicates to us in the serial monitor what's going on. So we're gonna go serial print. Okay. Now F, this stands for, I can't remember if I told you last time, but F stands for flash memory. And that basically helps this run faster. It stores this constant text value in special memory, all right? But in this case, because it's dynamic, it's a pin value right there. We're not gonna use the flash memory. And that's because we could change that value with whatever pin value we put in right here. So if we wanted to, we could do a loop and go pin 1, pin 2, pin 3, pin 4, pin 5, and so on. All right, now let's add a comma just for formatting. This is formatting the output text that we're gonna have, very much like we did with the temp sensor, okay? Cool, so the first thing that we wanna do is we wanna check if that input value is a valid integer. It should be, but in case something goes wrong with our script, then we want to have some backup check. So we're gonna say if is that's not a number, okay? So if it is not a number, if the input's not a number, then we want to go, we're going to leave ourselves a comment, by the way. You should never get here since serial input is in decimal. But it's entirely possible that something goes wrong, all right? Puts error. Cool. And if you want to be really good, you could also you could also state where you are. Input error in if conditional in buzz by input function. But we're not going to go that far right now. All right. So it does that, and when it does that, because this function is Boolean, we want to give it a return value so that it doesn't keep on going. So return false. Okay, that means that we broke something. All right. So what happens here is when we hit this return false, it basically ends the rest of the function, and all the way back up in our loop, this returns as a false value. We could use that if we wanted to. We're not going to in this case just yet. All right. Now, for our ifs, we don't have to, but we do like having else's. So we're going to go else. So if it is a number, if we don't end up in this if statement, if it is a number, we come down here to else, and we run something. All right. So for this else, we're gonna print that input, serial.print input. Okay, and remember that's gonna print after our formatted text here. So after that comma, we're gonna get that input value. Okay. So we print out the input, and now we're gonna take action based on what that input is. Okay. Now we're gonna just out of convenience go over to the instructions, and you'll see this. We're going to use R for run, O for off, B for buzz. Now remember, we will plug in the letter R or the letter O or the letter B, and our buzzer is going to do something based on that. But it's not going to be checking if the character is the same. It's going to be checking if the ASCII value is the same, all right? So that was that whole like 110, 114, 98 stuff. All right, so let's get started on that. So we're here, and now what we want to do is we're going to go if input is equal to 111, right? Do you remember what 111 is? Oops. So we're going to go back here. If we don't remember what it is, we can look at the ASCII table. 111 is O. So that stands for off, right? So we're going to go here. Oops. We're going to go right here. Turn the motor off. That's what low means, all right? And then we're going to go else if inputs. Oops. Do you remember what 114 is? We go digital writes, motor pin, comma, high. If O is 111, we could go through the alphabet, right? 112, 113, 114. And this says high. So if low is turn the motor off, we're turning the motor on. Cool. But we're going to go else if it equals 98. Do you remember what 98 is? Now what we're going to do in this case is we want whatever 98 ends up being, which if our choices are R, O, and B, it's probably B for buzz. We want it to do that. We want it to buzz, all right? So in order to make it buzz, for the motor, we turn it on or off, just like the LED. We set it to high or low. So we need to set up a for loop so that it tells it to go high and low based on our instructions, all right? So we're gonna go for ints. Now I is just a counting number, so we're gonna start at 0. I is less than the pin value that we plug in. I plus plus, increase by 1 each loop, all right? And we're gonna take those two lines we used before. Check this out. We're gonna go digital write, motor pin, high. That's to turn it on, right, to buzz. Then we're gonna put a delay in there, just like with the LED. Delay, MS. And we're gonna do that over 4. Just, you know, you wouldn't have to do that. You could go back and you could change the value of delay, but I'm doing it so that we have half a second delay, right? And then if you want to save yourself time from typing, copy, enter, paste. Now we turn the motor on, we need to turn the motor off and then have a little delay. And each, for the number of times you go through this, which is going to go, in this case, pin is 3, right? So it's going to go 0, 1, 2, and 3, right? It's going to go high and low. So buzz, 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 buzz. Cool. All right. So that's our for loop. That's our if else, but we need one last, or at least we want one last else, just in case somebody puts in an input that is not equal to one of these values. So we're going to go else for everything else that goes in, and we'll say else print line. Let's just add an extra space. Now we could use flash memory again if we want to, or we don't have to use flash memory. We're giving our users instructions just in case they made a mistake, all right? And we're reminding them what they need to put in. Oops. Or off, or B for buzz. Cool. And we close our else statement, and that closes out this set of conditionals, all right? So we exit this set of conditionals right here, which means that we finished up this else right here, right? So after that, we can go return true, okay? That is if everything works, all right? So again, let's go quickly back through this function. So this outside conditional statement right here, which is all of that, okay? It checks if the input is not a number. And if the input is not a number, then we want it to fall through. We want it to return false so that the function ends there, so that we aren't trying to figure out what's, you know, if the value equals something because it's not a number. Maybe it comes through as the letter A, right? If it comes through as the letter A, then we're going to get into this if is not a number, and it's going to print out this input error, right? Return false, and the function ends. Okay, when the function ends prematurely right there, what happens is it returns false here, back up in our loop, and just continues going through the loop, okay? But if it is a number, and that's this else part, if it is a number in this conditional statement, now we go into a new set of conditional statements, okay? And in this new set of conditional statements, we check if that input equals the value of 111, right? And that is, what is that? That's O. We should do that. What, ASCII decimal value? Yeah, sorry. ASCII decimal for O, all right? This is input is ASCII decimal value for R, right? So if the ASCII decimal value of input equals 111, then we turn it off, all right? We turn it off, and then actually what we could do here is we could go return true. I should have done that. That was kind of sloppy to not put that in the first place. If it equals R, which is run, it turns on the motor, and then it ends the function by returning true. Ends the function by returning true, which again comes back up here and returns true, and it doesn't keep on going. Or, you know, in the last conditional, or second to last conditional, else if 98. 98 stands for B, right? Input is ASCII decimal value for B. Cool. If it's for B, that means that we want to do this like buzzing, this pulse buzzing, instead of nonstop buzzing. And if the input equals the ASCII decimal value for B, then we go into this for loop where we start counting, and we go 1, 2, 3 up to pin number, and it goes buzz, buzz on, off, buzz on, off. Okay. Lastly, in this inner conditional statement, if the value is not the value for O, R, or B, then you get this this output statement that says that that the user needs to pick from one of these items. Okay. Okay. Now, once this inner conditional statement is finished, that's this else, right? Now it comes out here, that else is done, we can return true, all right? Now, if anything happens where there's a mistake and this buzz by input function runs, but we don't go into these conditional statements, let's return false. Because that means for some reason we skipped over all this stuff inside, which is not what we want. We want it to go through this, okay? What it would mean is it would mean that it was not a number, but we also somehow didn't end up in this else statement, which should have been guaranteed to run. So we return false. Awesome. I'm gonna have to upload this new code because that's a little bit different than what I had before. Now, this video is getting long, so I'm gonna speed it up. Let's go up to verify. Again, I don't remember if I said this in the last video. Verify only checks whether or not you have all the brackets, whether or not you have the end markers, whether or not things are defined correctly. If let's say I say incoming bytes, let's put an S there. Or yeah, oops, S. S is not working. Why is S not working? S, there we go, save. If I verified that, look at that. It says, oh no, something's wrong down there. And what's great is oftentimes this will tell us some information. Now, there's a lot of stuff here that can look intimidating, but if we go slowly through it, you can see you can scroll side to side. So let's expand that. If we go slowly through it, you can see that it's saying in this file, all right, in this file, which is our Arduino file, in the function void loop, that's our loop function right here, there's some error right here, right? That's what it says. It says right here, starting here, there's some error, okay? And again, it says it again, and it also tells you the location. You see that, 17.9? So I believe that's line 17, position 9. So if you take the cursor, we go 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go, all right? So line 17, position 9 in this file. And they're saying right here that the error is incoming bytes was not declared in this scope. Well, that makes sense because we defined incoming byte. If you look at the top, incoming byte. Nowhere do we define incoming bytes. And so the program, you know, what it tells us is it tells us there's a mistake here. Now, it'll give us another line that tells us more specifically, right? Right here, incoming byte, okay? Suggested alternative. Hey, that's pretty cool. Look at that. I never noticed that before. It suggests how to fix it. I don't know if you'll always get that, but if you do, that's pretty cool. And then at the end, it just tells us, you know, it tells us an exit status and it tells us what was wrong. If we go back here and we change it back, oops, change it back, we save it, we verify it, it works. Now let's go to the serial monitor. All right, that's from some other stuff I was messing with that I showed you. Cool. All right, so everything should be working, right? And because we aren't plugging anything in, loop is just running really fast right now, right? It's just running. And if you need proof of that, we could sneak in here and we could go serial.println loop running, okay? We could save it, we could upload it, and I'll show you what that looks like. And that's just to convince us that something's going on. Watch this. Loop running, and you see it's running super fast. Now, what happens if we put input in? Oh, look at that. Totally got spammed because that loop is running super fast. So we're gonna go back there, let's comment that out, save it, upload it. Oops. And, all right, are you ready for this? Oh, that's a little red over there. So it's uploaded. Let's go serial monitor. Let's clear the output. All right. Now the loop's running. We just don't see it. Check this out. What if we plug O in? O. All right. So it says pin 3, which is where the buzzer is, tells us our pin, and it tells us the value, and nothing happened because it's off, right? Okay. What's another one we could do? We could do run, R. Ooh, uh-oh. You see how that's there? We got to put a print line in there. I made a mistake. So ours run, it's just gonna keep on buzzing. But let's go back down here and if we look at the serial monitor, we can get a hint. So after buzz by input runs, so at the end of the buzz by input, let's print another line, okay? So, oh, that's gonna be messy. Let's do it before instead. Cool. Save, upload. Awesome. Let's go back to the serial monitor. Now we saw it looked like that, right? So let's try this. Let's go off. Cool. Run. It's buzzing. Now let's see what buzz does. B, buzz. See that? 1, 2, 3. Buzz, buzz, buzz. And it's done. Buzz. Cool. Now you have created a Arduino setup with a buzzer that takes your input and then it acts based on it. You can stop here if you want to, or as always, there is something more. Now I'm not gonna do a write-up for this one because I think I want you to take the code and I want you to take a look at some of this, all right? So let's come down here. Cool. So this right here, this was the really simple setup. We're going to practice using a breadboard and a little bit more now, all right? So let's go over here. So a breadboard, I don't think I've described this to you yet. You can ignore me if I have. The way a breadboard works, you can see a couple examples here. There's one I hacked up. Here's a beautiful one that I like setting it up like this so that the negative's connected like that, positive's connected like that. All right, cool. So the way breadboard works is for these long terminals, all of these are connected. Going down this, all those are connected. All of these are connected. Along that way, all of these are connected. And then along these lines, horizontally, it's connected. Okay, it's connected there, it's connected there, it's connected there. But in between, vertically, it's not connected, and horizontally here is not connected. Okay, that way we can have negative terminals, positive terminals, and then we can have lines that we can use for the same thing. Now, we go over to a naked board, all right? And this this only has one direction. It has this, if I rotated it, it would be horizontal. You can see, these are all connected, okay? Right here, these are all connected. These are all connected, and then those are connected. So what we're gonna do here for this advanced one, we're gonna take the past two projects and put them together. We're going to use our DHT22, and we're going to use that in pin 2 like we did before. We're going to take our buzzer, and we're going to use the input from the DHT22 to determine whether or not the buzzer buzzes, all right? We want it to buzz if we go outside of a temperature range that we like. Cool. So now, this is important. So this is all going to be negative. This is all going to be ground. This is all going to be positive right here, okay? It's going to be 5 volts. But then for the buzzer over here, we're going to do one connection, okay? There's the connection to the buzzer input, and I'm going to use that green one for that. And we're going to go into pin 3 for that. And then for the DHT22 right here, that's going to be our data out of the DHT22, okay? And we're going to use this yellow line right here. So these two are separate, because one's going to be doing one set of things, the other's going to be doing the other set of things. And the way that we're going to hook that up is we can unplug stuff from our Arduino. We're going to come over here. I'm actually going to put the camera down so I can use 2 hands. Cool. And so we're going to go, remember, that's the ground line, so we're going to put that in ground. Okay, positive line over there. Going to connect that to 5 volts. Okay. In this case, I'm using yellow for the DHT22, and we said that that was going to be pin 2, so we're going to do that into pin 2 here. And then we're going to do the buzzer into pin 3, okay? So we're going to go here, buzzer into pin 3. Awesome. All right, now we're set up. Cool, 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 cool. All right. Now, here's the exciting part. Now this can be done in a very simple fashion. I did this in 5 minutes for Gina before we went out on our date night, just to show off that we could do it. But you and me, we're gonna do it a little bit more complicated, all right? Now, I'm not going to step through all this because the videos already get pretty long, and I have full confidence in you that you can look at the code, you can copy, paste, play around with it. I will briefly tell you about the different parts. So first things first, we are basically going to combine the past two programs that we did, Project 2 and Project 3, okay? Which means that we have to include the libraries from Project 2. We want to define the DHT22 pins, create a DHT instance of a DHT sensor. But then we also have the motor pin stuff, all right? We got our delay. We start our serial connection. Now, our serial connection is going to be used for both input and output right now. It's going to take the data from the DHT22 sensor, the temperature. It's going to put that on the screen, but then actually we're only going to use it for transferring that because all the stuff's on the Arduino. In the future, we'll be using it for both. All right. Oh no, I'm sorry. It's going to take our. No, yeah. All right. So you can look through this. This is just the same stuff from before. Now check this out. Let us put this read sensor and print function in. All right. We're going to take the DHT22 and the pin number. We're going to have our if serial is available. Okay. We're going to come down here. We're going to check if that incoming byte is not a return character, and if it is not, then we can do this buzz by input. All right. So the read sensor and print is going to get us the temperature values, and the buzz by input is going to do its job also. All right. Now I'm cheating a little bit here, and you'll see how I'm cheating. We don't actually necessarily need all of this, but let's come down to this buzz by input. All right. So buzz by input is going to take an input. Same as before. You'll see this is all the same as before. Okay. All right. Cool. All right. And we can actually put our return values in there now. So let's go back and see what those return values are that we updated the code with. So if it goes low, all right, so if it gets here, we're going to go return true. Okay. Oh, I remember why now. Actually, no, don't. Remember how I said that we needed to add that print line? Well, if we don't exit the function, then when it finishes these, it actually gets to this print line right here, which we want. And that's our little buddy red. So let's actually take this return true. Boop. We're going to take that. We're going to take it down here. Okay. Cool. All right. Now, here's the thing. That's our buzz by input function, right? Come on, bud. Ah. All right, we gotta put Red outside. Whoop. We're gonna take a little trip. Hey, buddy, you love sharing and chatting with people during the videos, right? Yeah. Well, you can also chat with your friends out here. Eventually, I want to make a better corral for him, but this will do for now. Good boy. He's the sweetest rooster ever. He only attacks shoes. He's got a taste for high fashion. That's shoes, any type of shoes. All right, bud, we'll be back. All right. Ah, the cob. Check that out. So, I'm gonna hurry this up. Awesome. All right. Now, oh, I'm hungry. I need some breakfast. Cool. Now, we come down to this read sensor and print function, right? All right. So we got all this stuff we've used before. Cool. This is if we have a temperature error. All right. All right. Now this should be new, except for right here. So we're going to print out the temperature Celsius and Fahrenheit. That's because I'm trying to figure out why we're not getting a certain precision that we should be getting. But check this out. So this is where we're going to use our buzz by input function. All right. So if we come back up here, we could actually we could comment out all of that. All right, and we could just have read, sensor, and print, because read, sensor, and print. So actually, I'm gonna save. I'm gonna comment that out. Read, sensor, and print actually calls the buzz by input function. All right, and that's down here. So if the temperature is an error, 404, right? Then we want to send the buzz, that pulse, that bzz, 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 and you could put a different value in here, all right? You can play around with this value, and it'll tell us that there's an error with the sensor. However, then we want to see if the temperature is outside of our preferred range, okay? We like a temperature in the 70s, I don't know, between 70 and 80 degrees. So if there isn't an error with the temperature, okay, then if the temperature is less than 70 or greater than 80, we want it to just run the buzzer, bzzz, just nonstop, all right? And tell us that it's outside of our preferred temperature. And we got to get it back within 70 to 80 degrees F. And if there's no error with the temperature, we skip this. If the temperature is not less than 70 and not greater than 80, that means that we're between 70 and 80 degrees, okay? That's when we enter this condition, and it turns the buzzer off. Cool. And we have our temperature converter function. So let's save that. We're gonna upload it. Upload it. All right. Uh-oh. This error, do you remember this error? That error is telling us that the serial connection is not correct. So we gotta go up here, COM12. It says, interesting. I wonder what's going on. Well, it may be, if we have the serial monitor open somewhere else, sometimes that can cause a problem. Huh. All right, well, let's go turn that to COM1. We're gonna go back, turn to COM12. Let's try uploading it. Oh man. Now we get to troubleshoot live. Nope. Baffling. I'm gonna unplug, so I'm unplugging it. I'll plug it back in. And if that doesn't work, I'll try a different serial port. Arduino has this thing where it gets confused sometimes. All right. So we verify. Everything verifies, all right. We upload. Cool. You see that? Just unplugged and replugged and it worked. That's it. All right. Now, oh, you hear that buzzing? I wonder what that means. Let's open the serial monitor and it'll tell us. Look at that. All right. Now, see this pin 3114? That tells you, again, that's from the buzz. That tells you what value is getting pumped into that function. So what I want you to do now is I want you to take the temp sensor and either put it in your hand or put it next to something warm, because right now it's too cold. It's less than 70, and look at that temperature's going up. All right. And there we go. You see that stop? That means we're within the temperature. Now I'm gonna keep it in my fist. Our hands get really warm, right? Look at that, it's going up. Now I haven't figured out why we get this duplicate lag. I have to go and check the code that I'm working on with you against the code that I did for our sensor system, because our sensor system has better precision. I think I must have slipped something up. And it may have to do with, I mean, you look at the Celsius, that Celsius is going up, but Fahrenheit isn't, and that has to do with that conversion value, right? It seems to only be going in increments of certain degrees. This may be due to the data type that we used. We're not gonna stress over it right now, though. All right, so we're going up. And a nice tight fist. You could get a hair dryer and put it on it. You could boil a pot of water, which I'm gonna actually do right now because that might be faster. All right, 78. A little bit more. My hands are also pretty cold because it's cold today. In fact, it is 73 without the wind. All right, let's blow on it. Look at that, 84. So below temp, above temp. If you go outside the temp, it buzzes. And we're gonna give it a minute. Now, if you want to cheat, what we could do is we could go back and we could uncomment this and we could turn it off, but then it would go back through and turn it back on again. Look at that. Awesome. Now, if you did this advanced part, then you figured out how to handle input and output and also do some sort of action or reaction based on that input output. We got the data from the DHT22 and we learned about that in project 2. And we used the data from the DHT22 to compare to a certain value range that we wanted to work with. And then we had the Arduino take that, it compares that value, and then it responds via the buzz function to tell the buzzer either to buzz or to turn off. How cool is that? You're doing awesome. If you made it to project 3 and to this advanced portion, good job. The next project is gonna be awesome. I've always wanted to play with these. I didn't know whether or not we could make it happen, and I think you'll be pleasantly surprised. All right, you have a great time. Happy building.